Alright, how we doing today? Doing good? What is convolution? It's the raising hand thingy, whatever he tells you. Well, are we joking? Okay. I'm not gonna go over. Well, if you don't know convolution by now, then good luck studying for the exam, because the exam is gonna be based off convolution. And LOL. But for today, we're going to try and review for the exam, and I'll try to show you what I have for you guys. Actually, no, let's just go right into the meat and cheese of today. Let me see. Let's go to my little web page, which I edited an hour ago, so I've been working pretty hard. Yeah, just exactly 1 hour ago, I've been working on your little quiz, which can be found right here. Boom! There you go. There's your exam. So you guys can read that. Find the zero input response of the given system. And where's my water? Oh, here it is. Oh, yeah. Where's my water? Don't worry. I'll die of thirst.
Is it a water bottle or?
It's in a box. I don't know where it is. It's okay. So I say find the zero input response of the system described by y of n. Oh, there's my box. Thanks, man.
Dan, you want to help him out? No, I'm just I wasn't paying attention. He said right there, like, be thirsty.
Y of n minus 2r cosine yada yada yada. But does this look do you guys recognize what this is from? Actually, let me see if I can do this. EE360. There we go. Homework assignments, and by the way, your homework assignments due tomorrow 10 a.m. but for those with OCPD, just treat it like if we're due midnight tonight. Shouldn't be that bad. Due tomorrow 10 a.m. don't forget that. And look at that, it's your computer assignment. So suppose you're saying, hey David, I don't know if I'm doing this right. Is this right? Is this wrong? So there's two ways of doing this assignment, and the two ways you're doing it for the first half of the assignment is, one, you're implementing a for loop, so the delay stuff that you see in direct form 1 block, and you're also using the states, like the next state systems. So there's a third way you can do this problem, and that's the second half of the assignment, which is just using the actual H response. So instead of plotting Y and all these X's and Q's and stuff, why not just plot H? Just the thing itself. So, alright. If we were to look at this system and we were going to do your little quiz, and I'll just write that here. Actually, before I even talk about this, you guys know what I'm talking about when I say zero input response? ZIR, zero input response. What is a zero input response? The response of a system to zero input response. So you look at your system, and then it's just gonna spit out, actually I just do this, H of n, and it'll just spit out whatever Y, Z, I, R, whatever it's gonna spit out. So X of n. So for your little quiz that I've had, and hint, it's an exam, it's literally the exam. Let's look at it. Let me just pull it out. There we go. I'm going to write that on a second sheet of paper. And, oh, there it is. It's my phone. Alright, let's just start doing your exam. You guys are going to get 100 on this one, right?
Yes, sir.
Don't fail me now.
Don't tell me now.
Okay. And I'll do this. Y of n minus 2r cosine, I'm just rewriting stuff, y of n minus 1 plus r squared y of n minus 2 is equal to r sine omega naught, and then x of n minus 1, and that goes right here. Alright, so your job is to determine the zero input response. When you hear zero input, what does that mean? And let me just move this right here. What does that mean?
X is 0.
X is 0. That's literally how you play the game. So see this input right here? What do we do with it? Just make it 0.
0.
And who's in the chat? Oh, there you go. Yes, thank you. So that's all we do. So, okay, since we have OCPD, well, I do. We can just rewrite the equation y of n minus 2r cosine of omega naught y of n minus 1 plus r squared y n of minus 2 is equal to 0. All right? You're seeing that? So this right here, we're just looking at the 0 input response. So we just forced all our x's to 0. There's nothing in our system. It's gone. All right? We're just purely looking at these outputs. So if you recognize this, and I think you've seen this probably in one of your math classes, 141, 142, I don't know which one it is, where they call this thing, they call these things called the auxiliary equation. So, or I think that's the right term, characteristic functions. So there's a way Dr. Stubridge shows you in the book, but we're here to do stuff. We're here to solve stuff. We're here to get 100 on this exam. So the way you approach these types of problems in terms of digital, so we're looking at a digital. So this only works in the digital domain. There's an analog domain, but we'll probably show you that next week or 2 weeks, where you look at your delays. Right here's 0 delay, 1 delay, 2 delays, right? And you replace all the what do you call it? All the outputs with the characteristic function. Where, let's see how to model this. I'm just going to put it on the side, where we're going to have some auxiliary value, vector, or not vector, variable lambda is what we're going to call it, which is a function of n. Do we call it capital N, which is equal to y of n minus n. So this is going to be our little tool that's going to help us. So that means all these outputs, you're going to replace them with these auxiliary equations. So we're going to get the following. What do we get for this first output? Lambda. It's the lambda. That's a funny lambda. Minus 2r cosine omega naught. And then since we have yn minus 1, what do we replace that with? Since we have 1 delay, that means we get, I think this should be a plus. There we go. Lambda to the minus 1. Okay? Plus r squared. Yes. And then here we have 2 delays. So that means we got to have lambda to the minus 2. Simple, which is equal to 0. All right, now this is where the OCPD kicks in. There's 2 realms of solving this problem. But you can either solve for, so you're very, actually, what am I doing? This right here is, no, wait, no. 0. Wait, no. Wait, keep that there. Lambda to the minus 0. So, sorry, I made a mistake right there. Oops. Hello? Yes, what's up?
Wait, so for the 2r cosine part,
Yes?
n is 1, correct?
N is 1.
And so if it's lambda to the positive n, should it be lambda to the positive 1? Or the negative component? I guess what I'm asking.
Actually, I know what you're talking about. Because I'm trying to figure out something. So whatever you see here, so actually let me explain what I was trying to do. So you see, actually let me rewrite this. So the way I'm looking at this, and this is the way I'm trying to hopefully point this out to you, is if I do this, I'm gonna write this in, no, green's bad. I'm gonna make it red. Okay, that's red, right? That's a minus sign, it's red. Okay, minus. Okay, n, right? So I'm carrying this part, and I'm putting it right there. So okay, there you go. That makes more sense. So just ignore that. Okay. So for this first term, since there's no delays, then we just put the 0 right here, right? So that means this term is just a 1. Okay. Does that make sense? Oh wait, does that clear your question?
Yeah, that makes sense.
Oh yeah, you're on the board too. We can see see ya. All right, so finishing this problem. All right, so the OCPD kicks in. You can either solve for your negative lambda thingies. Here's your -2. But for me, I kind of like it like this. So I'm going to do this, multiply the entire thing by lambda squared. Is that good with everyone, Ray? Right? We're going to multiply lambda squared here. Lambda squared by 0 is going to give you 0. Then this goes into here, here, and there. So that we get the following. Lambda squared minus 2r cosine omega naught lambda to the 1, okay, plus r squared is equal to 0. All right? All right, so now the following tip I'm about to show everyone is, let's see, how do I want to show this without making it complicated? So you can either solve this problem two ways. You can either solve it the mathematical way, or you can solve it the DSP way. So the DSP way I'm about to show you is, you guys aren't probably going to get this one, but we'll try. Let me see. Let's try. I'm going to try this DSP way. So I'm looking at this cosine term. This cosine term, there's a realm that we can play with, and the realm that we're going to play with is called Euler's equation. So Euler's equation. Where cosine of omega or something like that is equal to 1/2 e to the j, positive j omega naught, or plus e to the minus j omega naught. Okay? So what we're going to try and do is, this cosine is going to bother us when we're doing all our square terms. So I'm just going to substitute this into this cosine. And I'll show you that in another page. Yeah, what's up?
Sorry, I kind of spaced out. Why did he times everything in red by lambda squared?
So it's just OCPD. It's just OCPD. So you know how you can solve for this lambda squared. You can keep everything in terms of, well, it's a second ordered equation. You can do x is equal to negative b plus or minus, where you're doing x to the negative something is equal to all that song. You know what I'm talking about. So you can do this. You can keep this negative, but because I'm trying to use that quadratic equation, the second way, so the first way I'm going to show you guys is this DSP way. The second way is just doing the quadratic equation, which is equal to this lambda is equal to minus b plus or minus the square root of b squared 2a. You know, that thing right there. So that's the reason why I'm multiplying it by lambda squared, so I can get positive 2 on the top, positive 1, and the 0 term right there, lambda to 0. So that's what I'm trying to do. You can do this, but this is painful. Trust me, it's going to be painful. But this DSP way, because we're going to go into the Euler's equations, should be easier. So back to what I was trying to say. So 3, and that's annoying me. There we go. So rewriting this equation, we're going to get lambda squared minus 2r, and I'm going to do this 1/2. Just do this, e to the positive j omega naught plus e to the minus j omega naught. So that's the term we just replaced, plus r squared is equal to 0. And forgot a lambda here. There we go. So, all right, making sense? So now the next thing we're going to do is we're just going to replace, we'll just start multiplying stuff into this. Just multiply, and we'll analyze what I'm about to show you right now. So lambda squared minus r e to the positive j omega naught minus r e to the minus j omega naught, and this is all lambda, plus r squared is equal to 0. So what I'm going to try and show you guys, and let me see if I can get my polls right. There we go. How do I want to show you guys this without making it look confusing? I'm trying to figure out a way to show you this, because, let me see. It's not coming to my head.
Don't fail me now.
I'm trying to not fail you right now. I'll get there. Gosh. I'm trying to remember it. Wait, why am I doing this? There we go, that's a positive. It's not clicking to my head for some reason. Don't worry. Point is, this is going to eventually evaluate to, and I'm having a hard time remembering this, but what I was going to try and get to you guys is, eventually this characteristic function, lambda, is going to have to equal re to the plus or minus j omega, and that's what I was trying to get to you guys, but let me see my quick notes. Actually, no, I have a note I was basing this on. You want to know where I was getting this problem from too? If we go to ComSys, steps 360, just to, if you guys wanted to verify your problems, or no, not that one. That's a surprise for later. Let me see, because he doesn't solve it. I'll show you what I'm talking about. Where is it? It's right here. See here, this is the same problem, by the way, so if you guys wanted to practice another problem for your exam, this is from the book. I'm literally pulling this from the book. So what I'm trying to say is, your exam is based off the book. So he has this, and he doesn't solve it, he just does this. So lambda 1 is equal to this re to the positive j omega, re to the minus j omega. But you guys can solve that on your own. But the point is, I'm trying to get to the big point. So after solving, you get this. You get 1 and 2, which is equal to this. That's going to be your lambdas. That's going to be your auxiliary equations, or your variables that you'll have. So after doing this mathematics, you can find this on your own. Shouldn't be that bad. By the way, this exam problem we're doing is much harder than the actual exam itself, so you guys are going to be set. Once we have this, there's a general equation that we're going to punch this into. And the general equation is basically, okay, y is equal to zir of n. Is we're going to take a guess. The guess is, well, when you did the auxiliary equations, the guess is going to be whatever constant, some constant coefficient, we're going to call it c of 1. And let me remember, wait, let me pull this out. No, I got this. Lambda to the n. There we go, yes, lambda 1 to the n. So this is your assumption for all analog, or not analog, digital systems. We're going to have c of 1, some constant coefficient, some amplitude, times our characteristic function or variable. So c1 lambda to the 1. But since we have two of them, c1 lambda 2, or c2 lambda 2 to the n. And let me just verify that in Dr. Stever's little thing. There we go. Yep, there we go. Yeah, following the book. And then continuing on with what he has, because this is going to look like a cool output. After punching in these characteristic functions into here and here, we're going to get c1 re to the, let's do positive j omega naught n, don't forget the n, plus c2 re to the minus j omega naught n. Alright? Alright, and if you can get to this point, then you're set for the exam. So now the next thing is to find out what these c values are. So if you go back to our little quizzy, we go back to here. What did I say? I give you the following outputs. Let me pull out another piece of paper. We're going to set our equation. So I say y of 0 I'm just gonna write right here, is equal to 0, and y of n is equal to -1. Don't worry, I'll show you guys the screen. Sine omega naught, and y of n minus is equal to -r minus 2 sine 2 omega naught. Alright, there we go. Chat. There we go. So, I give you guys these states, and if you recognize this, this is from your actual homework assignment. Okay? So the goal is we're going to try and get an impulse response from this, from the zero state input response. So now, we have our general equation. This is going to be some solution. This is a general solution, but we want to find the exact solution. So all you do is, if you're given points, just plug and chug. All right? So the first thing we're going to do is, I'll show you this. So the first point we're going to look at is at n is equal to 0. All right? N is equal to 0, okay? Which is equal to 0. All right? I'm going to call this step 1. And that is equal to, well, C of 1 R e to the positive j omega, and I'm just gonna, just punch in the 0. Use a green. 0, okay? Plus C2 R e to the minus j omega naught 0. So when you have a 0, you see these zeros right here, right? What happens when I have e to the 0? You guys know what that answer is? E to the 0. Favorite definition, 1. So that means this entire term just turns into 1. Okay? 1. 1, alright? Then rewriting this, C1 R plus C2R, but we know that these R's just cancel out because, well, just divide it out. And you'll figure out that C1 is equal to C minus C2. And this should signify something pretty cool right now, before we even solve this problem. Basically, this term, whatever this value is going to be the same value here, but just negative. Ah, see? Pretty cool. And I'll show you guys a pretty cool trick after that. So we just established this. Now the next thing is we're going to do number 2 right here. Second state. And do you think I'm going to fit this all in one page? Y of n is equal to -1. And what did I say it was equal to? It's minus r minus 1 sine omega naught is equal to, let me see, C of 1 r e to the, what did I do here? To the j omega, I know what I did, minus 1, because we have an n minus 1 here, so that just flips the sign right there, okay? Plus C2 R e to the minus j omega minus 1. Okay? You guys are seeing that, right? So the reason why I'm putting this minus 1 is because of this n is equal to minus 1. Alright, we're just replacing that n. Oh, chat saying something? Yes. So now after doing some wild substitutions, minus r minus 1 sine of omega naught is equal to C of 1 r e to the j minus j omega plus C2 r to the e to the positive j omega. Is everyone following that? Making sense? Alright, so I'm going to rewrite this on another piece of paper. This is page 4. Okay, let's do this right here. Let me see. So now what we're going to do is, if you've noticed, so we have our little condition here, right? We have C1 is equal to minus C2, right? So what I'm going to do is I'm going to replace, let's replace this term, okay? So we're just going to replace C2 in terms of C1. So in other words, C2 is equal to minus C1, okay? So we're going to do the following. Minus r minus 1 sine omega naught is equal to c of 1 r to the e to the minus j omega minus c of 1 r to the e to the positive j omega. Alright, so now the next thing I'm going to show you, and you have to learn this too, is another little DSP trick. So we have a C1 and a C1 right there, right? So actually, what I'm going to do first is, do I want to do that? Nah, I'll show you this right now. So, okay. I'm going to put a plus there, a minus there, and a plus there. Does that bother anyone? Nope. Alright, cool. So the next thing I'm going to show you is there's a thing called sine omega naught, okay? Which is equal to, we're going to do Euler's equation, is equal to 1 over 2j, where it's multiplied to e to the positive j omega naught minus e to the minus j omega naught. Alright, so that's the pattern that I'm going to try and show you guys here. So the easiest way to memorize sines and cosines is, well, where's sine and cosine? Now I'll just show you this. Well, this sine right here has a difference between these two little exponentials, and there's a positive and a minus frequency, so that's the trick I'm trying to show you. But the sine consequently has this 1 over 2j. So what we're going to try and do is, you see this right here, here's a positive frequency, and then here we have the negative frequency, and they just have the same amplitude. What I'm going to do is, well, first I'm going to multiply this by 2j, divided by 2j. We're just multiplying by 1 to the entire thing. You guys following that? Okay. And what I'm going to do is I'm going to borrow, so we're going to look at this term right here, and we're going to just change this in terms of sine. Alright? And then we're going to get the following. 2j and sine, let's see, 2jr sine to the omega naught. There you go. Which is equal to r minus 1 sine omega naught. Alright, does that make sense? And where did my C1 go? C1, there we go. Following?
You can also, really quick, you can also set that up as a quadratic and solve it from that way.
Quadratic?
You said previously you could solve it without using infinity.
There's no power terms. This is all constants. This right here is a constant. We're just solving for C1. Okay, here's C1. If you didn't see.
Like from the beginning, right?
Oh, from the beginning?
Like when you said there's 2 ways to solve this.
Oh, no. I was talking about there's 2 ways to solve for this right here. This weird equation that I was trying to solve out for you all. 3, 4, first page 2. This characteristic, the actual auxiliary equation. There's 2 ways of doing it, but we're not going to do the second way. That's just to solve for, where is it? That's just to solve for this. So right now, like the work to get to here is, the way Dr. Stubert's going to exam you, it's not going to be this hard. If I couldn't do it in like 2 seconds, then you guys are going to do it in 2 hours for the exam. So it's going to be numbers. It's going to be easy. But the way we're doing it right now is the hard way, and it's your assignment too. Okay, so now back to the class. We're going to cancel this out. We have a sine in here, sine omega naught term here. We have a sine omega naught here term. We can cancel those out to get r minus 1 is equal to r2j c1. Okay, and then if we just move stuff to the other side, and is that right? I feel like I should have another term. Let me see something. Something's wrong. C1 is equal to 1 over 2j r minus 2. I think that's right. Yeah, we'll figure it out. Don't worry. So now that we solved for C1, okay, now we can solve for C2, which is just basically the negative of C1. which is equal to 1 over minus 1 over 2j r minus 2. Alright? And now we can finally solve for our general equation right here. Okay? And someone's probably asking, hey David, why didn't we use this right here? We could, but I don't know if you see a pattern. This right here, okay, this right here is a minus 1, and this right here is a 1 tucked in there. This right here is a minus 2, and this right here is a 2 tucked in. There's a pattern. So Dr. Stuber is just giving you this just to solve your problems or finish the computer assignment. But for us, since we only have 2 characteristic or 2 equations or 2 lambdas to solve for, we're only going to use 2 states. So that's what he's going to give you on the exam, just 2 states, y is equal to 0, or whatever is equal to n equal to 0, and n is equal to minus 1. All right, that's what he's going to do for you on the exam. So now we can plug and chug our, oh, now it makes sense.
What
Oh,
was the point of the third state?
third state? Did you do your assignment? Right here. So the point of me putting that third state is to like see if you guys were really OCPD and questioned about it. You don't really need it. I just put it there because it was based off the homework assignments thing right here. So right here, y is equal to, n is equal to 0. You have y is equal to 0. Here's these 2 states right there. It's just for your assignment. But for your exam, depending on how many the power of your auxiliary equation, so if you have a second order auxiliary equation, you're only going to need 2 states, which is what's going to be on the exam, second order. But much easier than this. So back to what I was trying to say. We can now plug in our C's to get our final value. And oh god, I lost what page this one was. Let's just guess 5. Alright, no wonder why Dr. Baker writes the page number first. You see that in all his videos? YZIR is equal to, and I'm just going to punch in numbers, 1 over 2j r minus 2 plus, or times, r e to the minus j omega naught minus 1 to the 2j r minus 2, okay? R to the positive j omega naught. I think that's right. No. Oh, no, this is positive, sorry. This is minus. Ugh. There we go. Alright, so everyone sees that, right? We got this term right here, positive. This term right here, negative frequency. Alright, following? And then we can rewrite this as, let me do this, 1 over 2j, and since, let's just start combining these r's already early. Does it bother anyone if I do this? R, multiply the r into the front right there to get the following, e to the positive j omega minus e to the minus j omega naught. Because you see the pattern? Remember what we did with the sign, the first sign that we were encountering? We're going to do the same thing for this one. So, looking at this, we do have this term right here, right? And we also have this 2j right there, right? Which means we can replace this all with r minus 1 sine omega naught. And there you go. But before that, your real answer is kind of this. Your real answer is, well, I'll multiply it by the unit step. Don't forget that. If you forget this, he's going to take off 1 point. Trust me.
What?
Trust me. Yeah.
Oh, the unit step.
The unit step. Alright, who's ready to prove this? Alright. That was the whole point of me doing this quiz, to prove it. Show you guys you can do this. And I will pull out this. So I've been working on this one right here. There we go. Pulling out some MATLAB. And let's see CLC, clear vars. There we go. So, if you've already guys done your assignment, this is 10. This right here is your direct form 1 block. Really simple. You can do whatever you want with it. Here's your direct form block. Okay, makes sense? So right here is just our check to like, oh, how do we do a zero input response? So if you've done your code, right, you're like, oh, you got that B1 times X. If we're going to do a zero state response, what do? You can either, 1, just set all this to 0, or 2, you can just do it my lazy way, just chugging a 0 right there. And now we're just looking for our states. All right, this is the way you do it in your programs, your building programs. And then let's do that. All right, so this is what you're going to see on your assignment. And then someone was asking me this, David, it's not looking like my thing. It's the state responses are weird. And if you're really OCP about these 2 points right here, someone was asking about these 2 points. Okay, just build yourself a unit step. Okay. And go down here, dot times unit step. Does that clear your guys' OCPD? No. It's okay. Alright, now that's what you're going to see in your programs. This is the solution. Do you know how to get to it? Now you understand what's going on. If you don't know how to build the program, but you can do it mathematically by solving for the ZIR, you can type in the following. So, looking at our handy dandy this right here, we're just going to plug this into MATLAB and verify our code, or verify our program. So H above, because we're looking at the impulse response itself, is equal to R to the power of -1. Is that right? I feel like I have another positive. R1. Yeah, we'll figure it out. This dot times sine omega naught dot times the unit step. Okay, and then that's what I have right here. There's your quiz. And then T. There we go. All right, let's see what we get. Oh, that doesn't look right. Oh. You know what I'm forgetting? I'm forgetting something important. Where is my N? The N is actually tucked in. So there's an N right there. There's an N right there. N, N, omega naught N. There we go. And then, let's punch this right here. That can be that. Dot times N. I think I'm forgetting an N here too. Let me see. Actually, let me verify something first. I think my math got someone wrong. R of N. Forgetting an N in here. We'll verify it another day. Let me just run this. That's exactly what I want to do. So wait, let me just check. What did I do wrong? Okay. R of N. This is just a constant. Did everything right here. That's correct. That's correct. We're just solving for numbers. I think this problem started right here. E to sine E to J omega naught. Let me remember. Where's my piece of paper that I had? Point is, let's just replace this with N. I lost a variable somewhere, but point is, yes, you can do this by hand solving for it. And the problem I did here is much more harder than the exam. He's going to probably give you like easy fraction numbers like 1/2, 1/4, solve for the impulse response, where this number here has to be, and he's going to probably quiz you this, the value here A must be less than 1. Because as n goes to infinity, that means this has to eventually get smaller. Alright? So if he asks you, alright, if I give you a signal, here's h, your h of n is equal to alpha u, or alpha of n, u of n, determine the values of when A should be, where the impulse response is stable. And if you can't answer that, then just actually absolute value. He's going to take a point off. So if A is a negative value but less than 1, then it's just going to be a little oscillator. Pretty cool? And someone's on the chat. ZRR is on the exam. I really don't know. So from based off, I'm going based off my notes, but it could be a possibility. He did teach it in class Wednesday, so I'm like really unsure what he's going to try and do. But what I was trying to get to this right now is to show you on your assignment how you can derive the impulse response. If it's not on this Monday's exam, it's definitely going to be on the next exam, because the next exam is going to be total response, which is solve for the ZIR, solve for the ZSR. Now add them together. So for now, I actually don't even know what's on the exam because he's been really behind, I'll be honest with you. So
He's been behind on what? Like on his teaching?
yeah, a little bit of the teaching. Like we got to that last chapter pretty late, and then he was joking with the class saying it's going to be on the exam, it's not going to be an exam. So I'm just better to learn this now than never. Okay? So the point is, you can look at your system, your y's and your x's, determine the ZIR, and then verify it in MATLAB. Here's your quiz. Oh, here's your little quizzy. Here's your MATLAB assignment. Do they look the same? Oh yeah, they do. So that means we're doing this right. We're learning. So you can either do this heavy math, or you can do the heavy math on a piece of paper, and these two are the same code. And that's the impulse response due to zero input. So the next thing I want to lead up with everyone is, let's see, let me grab one more piece of paper, is how are we doing on the second half of the assignment? Is it going good? Is it going well? It's easy, not that bad? Let me show you. So if we were to look at the assignment that I have for you, like you're able to draw the direct form block diagram of the system, and then someone's asking, oh David, you didn't ask which block diagram, 1 or 2. Well, here's a hint. I'll draw it for you. And that, I purposely worded that way. I edited it and I know exactly where I'm putting this. So let's just say y of n is equal to b0 x of 0 or n plus b of 1 x of n minus 1, okay? So determine a direct form block of this in the direct form 1. So you remember direct form 1 is just, oh, we have this node right there, it goes down into a block like that, right? And then this would go into some gain b0 plus into some y output, right? dfi, right? Now, let's draw the direct form block of this one. And actually, let me show you this. So you know how we call this one C of n? And then we put this plus sign right there. And then we do this y of n. Alright, let's start feeding it back, okay? D of... Well, what's... Or... Got me there. A of minus 1. But what's A of minus 1? It's not there. It's 0. And what's A of minus 2? It's 0. So all this doesn't exist. There's no feedback. No feedback. So that means C of n is equal to y of n. That means your direct form 1 block is equal to your direct form block 2 block. Which what I'm trying to say is the basis of a direct form block is this is an FIR filter, or finite impulse response. Okay? So the definition of a finite impulse response is whatever you throw into your system, it just comes out. So it's not going to be unstable. So if you have this pole right here, then you'll have some feedback which is going to be infinite or unstable. But point is, the direct form block, either 1 or 2, since we don't have any feedback, they're the same. That's just a tricky. Trivial, really trivial. If you understood that, then good. If you didn't, then I would study. But do we know how to do the fourth, fifth, sixth exercise? Can we do that? No? The assignment's due tonight. No, just treat it. It's due tomorrow at 10 a.m. So if you know how to do this assignment, and I hope everyone's going to get 10s. If no one's asking me questions right now, then I hope everyone's going to give me a 10.
Well, you got to check the chat.
Chat?
Oh.
Someone on the chat? No, no one's on the chat.
Leave one alive.
I think the chat's chilling around. But what I'm trying to say is, you're trying to develop a program. So from what I said in the last lecture, you can build powerful programs just based by looking at the raw definition of convolution. So, I'm going to do this right now. We're going to have to go over the raw definition again. How to build a block diagram. Let me just pull this guy out. So if you were trying to implement this in code, so let's call h is equal to b0 and b1. Okay? So remember how we were doing all this stuff? So I'm gonna try and show you this mathematical way of doing convolution. Some x is equal to something, okay? So the way to do mathematical convolution, and I'll show you this trick now. No one else is going to show you this, and it might be on the exam, and if you want to, you can do this. Where y is equal to the convolution of h and x, okay? So the trick is, you look at y of 0, okay? Actually, let me do an example. Let's make it b of 2, okay? And then I'm going to call this one, let's call it C1 and C2, okay? So this right here is NH is equal to 3. It's 3 items long, and NX is equal to 2 items long. So that means our final, if we were to convolve these two signals, a length of 3 and a length of 2, how many calculations do we have to do? And a y is equal to n of h plus n of x minus 1, which is equal to 3 plus 2 minus 1, which is equal to 4. All right? So we're going to do 4 calculations. And I'm going to do this. 4 calculations. And the one thing I'm going to tell you is, suppose we kept h constant, okay? So h is going to be stuck in space. H is 0, h of 1, okay? That's going to be stuck in space forever. What you're doing is you're flipping this. You're flipping x, and then you're doing this circ shift. Circ shift is the keyword. So what I'm going to try and tell you is, if h is stuck in space, let's just force h to be h of 0. Okay, I'm going to do this. You tell me if this makes sense. Okay? So if we were to do the first convolution point, so let me do this. Here's h, and here's x, and h is basically, I'm going to do this. So b0, b1, b2, okay? And x is just 2 points long, okay? So the first thing we got to confirm is when you flip this, the first mathematical operation you're going to do is this and this. All right, so that means the first guaranteed point that you're going to put on right here is x of 0. Does that make sense? Then the next thing you're going to do is you're going to multiply this value to whatever's right here. But there's nothing there. So what I'm going to try and show you is h of 1, x of minus 1. Alright? Does that make sense? We're multiplying this next point times this next point. Okay? But this x right here, x of minus 1 is 0, so there's nothing there. It's just 0. Okay? And then plus h of 2, x of minus 2. You see the pattern? So what I'm trying to get to you is your h's are moving forward in time, and your x's are moving like this, backwards in time. Alright? You see the pattern? So now, if you really see the pattern, h of 1 and then plus h of 2. Are you seeing that? So, to solve for this next point, okay, if we were to shift this, right, like this, right, we're flipping x, and then we shift it. If we were to do y of 1, we're going to know we have to convolve 2 points. So the 2 points that we're going to convolve, and I'll shift it again. I'll just draw the same signal again. Okay, you see that same point right there? I'll do this again. 1, 2, 3. Here's h, here's x. The mathematical operation is we're going to multiply h of 0 right here, right? With, I remember, so if you flip this, and you shift it, x of 1. So this is going to get multiplied by this. And this point right here is going to get multiplied to this. And then this point right here is going to get multiplied to this, which is 0. Is that making sense? So the pattern is, you see this 1 right there, you see this 2, and you see this 3? Copy this one right there. And then copy this 2 right here. Copy this 3 like that. And you know how this x goes backwards like this? So if, that means if we're going this way, see here it's x0, x minus 1, x minus 2. That means this is x1, x of 0, x of minus 1. And then you see the pattern. You start seeing the pattern. Oh, that's the keyword of the day. 3, 2, 1. And that right there, I'm calling it like David's weird mathematical way of solving for any convolution problem that Dr. Stuber throws at you. Mathematically.
You should work on that title.
Yeah, I'll work on that title. So, okay, point is, you see here we have an x1 right here, right? X of minus 1, which is right here, is 0. So this is 0, it's gone. X of minus 2, also 0. Here's an x minus 1, so that means look at all the x minus 1s, just cancel them out. So this is gone, and that's gone. Okay? But now let me show you this. The next thing I'm going to show you is, okay, so that means we're adding 1 point right there, right? And now the next thing I'm going to try and show you, and let me see if this makes sense. X of 3. Oh, yes. So here we're going to see these 2 points. H of 0 and x of 0 are going to multiply. Here's h of 1, and here's h of 2, right? Those are always going to be, the h's are going to always stay constant. The thing I'm going to focus on, here's n is equal to 0 right here, right? Here's n is equal to 1, right? But here, n is equal to 2, we don't have a value for x. So that means you see this x of 2? That's also 0. Okay, and then x of 3 is also 0. And then the pattern I'm trying to show you, everyone, is x of 1 exists, h of 0 exists. H of 1, x of 1, h of 2, x of 0 also exists. And then you start seeing this pattern where you see this right here. Here we're only multiplying, adding and multiplying 1 point. Here we're adding and multiplying 2 points. This plus this to give us 1 point. And then we're doing the same pattern. You see, it's like this. It's like circ shifting like this. See that? So what I'm trying to get to you is if you were to develop a code to do this problem. And what time is it? 6:30. I wanted to get this point. So this is what you would, if you want, this is a third way of solving for Dr. Studer's exam for Monday. So that's the other way of convolution, digital convolution. Is keep your h steady, okay? But you're going to cross multiply this with the first point. The first point, so if this matrix is B0, B1, B2, okay? And we want to get this similar pattern where this first point's added, but this point's gone and this point's gone. So that means if X is right here, that means our first point, the Dirac delta itself, just make this one X of whenever it is, whenever it begins, whenever your pre-length plus something right here. So this is like beginning, okay? And now the next thing you're going to do is this next signal here is going to be X, or whatever your signal start. I'm going to call it start, okay? That means the next point is going to be start minus 1, okay? And then X start minus 2, and then you start seeing the pattern, right? Then why don't we just do it for X starts, and actually we're doing 1 point, 2 point, 3 point. I'm going to call this one length of H. Like that? So if the length of H is 3, that means how many points do we have here? 1, 2, 3. Alright? And don't forget, this right here is a 1 by 3 matrix. That means this right here has to be a 3 by 1 matrix. Okay? So that means if you want to develop this in your code, have the first point start like your beginning, whatever your Dirac delta function is. Then this one is going to be the point at n is equal to minus 1, minus 2, length of H. Is that making sense? And that means no matter how big your H is, just start with 3 points. Then add more points. And you're done. And that's how you would do it in code. Is everyone going to get 100 on this exam or this assignment?
Assignment and exam.
Alright. Now, the next part is, okay, how do I do the transpose direct form 2 block? How do we do this in code?
Same way. Oh, your chat is blowing up.
Oh, chat's blowing up. Where does the NX and NI? The 4? That's how many calculations we did. So here's NH and NX. We have a length of signal 3, a length of signal 2. When you convolve two different size signals, you add the sizes and then you subtract by 1 to see how many calculations or how long your output signal is. So convolving a length of 3 with a signal of length of 2 gives us a signal of length of 4. Does that make sense? Chat saying, okay, yes. So now I'm about to show you how to do the final code for your assignment. The transpose direct form 2. So if you were to do a transpose direct form block, which is B0 and B1, and this should be really simple. And I got a Q. Let's do Q1 and Q2. Okay? So, we're going to kick our box. Alright? When I say kick your box, we're going to throw an impulse response into the system. So the first thing we're going to do is, bam, there's a 1. Okay? We're going to throw the 1 and it just gets multiplied here. B0, B1. Alright? Step 1. We're going to just kick our box and now we have these B0 and B1 terms, whatever is being there. Okay? So the next thing we're going to do is, okay, we're going to set this Q1 or whatever is here equal to whatever is, it just gets spits out. Actually, if I show another branch, maybe it should make sense. Plus. So here's Q3, okay? And that's Q2, and this is Q1, okay? Is that making sense? So we're just, if we kick our box, and oh, there's delays here too. If we kick our box, whatever is at our input goes directly into our output. So what I'm trying to tell you is, if we were to create some code, all right, we're going to just shift everything into Q. So whatever our first point, so we're just going to get 1 point times So using the cross product or your thingy, your vector multiplication, h. So h is static. The point we're doing is just 1 by 1, and then this right here is, do I want to do that? 1 by 1 by 1 by n, I guess. N minus 1, because we're going to have 3. If n is 3, yeah, n, there we go. So, okay, one question. What was the value of this thing right here? So if Q1's right here, right? Eventually we're just adding this node and whatever is here, and we're just feeding it in, and we're just refreshing this Q. So initially Q1 is just 0. It's nothing. We just stored in some value, and now Q1 has a value. So now Q1 has a value, right? And let's say we throw another 1 in here, right? So whatever is here plus whatever is here just starts refreshing. So what I'm trying to tell you is, if you were to implement this in code, our next state is equal to whatever is in our current point plus our whatever was in the previous state. So this is a previous state, and we're just solving for our next state. So the next thing you're going to do is, okay, now that I've done the mathematical calculations, this right here is initially 0. We just shoved everything into Q. Now Q1 has a value, Q2 has a value, Q3 have a value. Since we know Q1 right here is going to have some value, y is equal to Q11. All right, the first point. And now what we're going to do is we're going to shift everything up using circ shift. Q, but if you want to move something backwards, use -1. But that means, okay, if we shift, okay, if this one has like some number, let's say 100, right? If we shift 100 up, it's going to come back to the bottom of this. How do we get rid of that problem? We just make Q of n is equal to 0, and we're ready to do the next calculation. Does that make sense? Is this going to be an easy assignment?
Yep.
And then in the end, well, that's your for loop. 4 lines of code. Easy. And in the end, both of your responses for your direct form 1 block and your direct form 2 block should give you the right output response. Does that make sense? So your job is you're going to kick your box at some time, store this value, and then you're going to save the top value and force the last value to be 0. Don't forget the circ shift. And then you're going to keep doing this to where if h is an infinite number signal, then you can get this right. All right, is that making sense? All right, so the last thing I'm going to cover, and I did say I was going to do a little quick. This is going to be quick. Everything we've been doing is literally preparing you for the exam. The final thing I'm about to show you is the raw definition of actual convolution, which is analog signals for general analog. So suppose you were on an exam and Dr. Stewart says, okay, I'm going to give you the following. Okay, he's going to give you 2 impulse response, or 2 boxes that are going to do its own thing. So, or convolve, that little hand thing he's doing. So here's X, and then let's call this some omega node, so some middle internal node. Okay? So, if you were to do this convolution, what is going to be the output of W? Or convolved. Alright? Does that make sense? And then the next thing you're going to do is, well, you're going to shove, and then this right here is just going to equal to your raw definition, n is equal to infinity, n is equal to minus infinity of x of, or no, k, I'm going to call it k, x of k, h of 1, n minus k, okay? And now you're going to punch this in to your y equation. So if you wanted to solve for y, you're going to do the convolution between y of n, or w of n, convolution with h of 2, which is going to equal, so I'm going to call this one sum L to infinity. L is equal to minus infinity of, this one's going to be a long one. Let me see. Shouldn't be that bad. W, we just replace all the k's. No, we keep the k's. K is equal to minus infinity of x of k, h of n minus k. So that's the input, but we got to replace L here. So I think you would have to do some weird substitution. We'll figure that out. N is equal to L. That means this right here. If N is infinite, that means L. You'll figure this out. But point is, actually, let me see if I can help you out with.
Study, right?
No. I want to help you guys out with this. Let me see. Just to get everyone into shape. So, one thing I'm going to tell you is, all impulse responses follow the same logic. Some alpha to the n, where alpha can be less than 1. So that means if alpha is a negative number, that means you're going to get this oscillation. And all impulse responses, so if you were to do an impulse response of this system, will eventually settle down to 0. Okay? So suppose he gives you this signal, and then suppose he gives you another signal. All impulse responses are going to follow this general format. So now, I'll give you 2 example signals, but I'll give you guys this for homework. Hint, hint. Try it. So, does anyone else have any other questions before we end this day? Everyone's going to do good on the assignment? Everyone's going to give me 10s? No questions from the chat? Let me see.
About the assignment or the...
Alright, because someone's probably going to... Yeah, what's up? Question?
Oh, no.
No? Well, I could show you this. Yeah, let me show you this. So someone's probably asking, okay, David, how do I implement this in code? R, and, do I want to do that? Let's do it right here. Wait, let me just pull this out. Pull this out. Alright, someone's asking me to, alright, let's see, can you tell me how to do this? So, suppose I had a play signal, which is equal to, let's copy all this. There we go. Pre-length, x. Alright, so the first thing is we're going to start with some input, alright? I'm going to just make it look like the impulse response itself. So then the next thing I'm going to try and do is, before you implement this in code, please do the following. X, DFI as an example. Create unique stuff. Do not manipulate the actual equation itself, else you're not going to be happy with the final result. So what I'm doing there is just creating a play variable. Okay? And then the next thing is, alright, so how do I implement this in a code? For I is equal to, pre-length plus 1 to pre-length plus 1 plus end length. Okay? Remember that stuff we were doing? Know why we're doing that? If you don't understand why I'm talking about this, then please let me know. So we're doing this because, well, we want to know, okay, we're looking at the previous point. We have this thing before n is equal to 0. And then this right here is our end length. How long is our signal? So if I were to do something for you, and I will show you this, where, how do I want to do this? Actually, no, let's not do this. Okay, where h is equal to, let's create a number, 0.5 and 0.25. Does that make you guys happy? So first thing we're going to do is we got to set some output. So I'm going to do y is equal to, let's just do some copy pasting. Yes, there we go. So you've already set your thing. Let's call this one, what do we call it? Setting up memory. Alright, where, let me check quick, looking at what I have. Because we created a variable 1i, we're just looking at the current time, which is equal to h cross. So h is going to be the play variable that's going to be static. So we're looking at this point and this point. So that means, oh gee, if I wanted to look at x right here, if we're going to look at, let's look at this, F9. Okay, now let me pull this guy out. This is what you should be doing in hand. Alright, where is our Dirac delta? You see that Dirac delta right there? So we want to start at, right there. We're going to start at x3. So whenever this is 3, and then we're going to look at this, and then we're going to look at that, okay? So this right here needs to be 3. So what is our pre-length? Actually, let's do this. Force this. So can you agree that, let me see, n plus 1. Can you agree that this is 3? So if I were to do this, F9, what is the value of n? 2, right? So that means to make this a 3, we just add a 1 right there, right? And then whatever we do with there, we just copy it right here, n plus 1, okay? Is that making sense? So going back to our direct form 1 block, we want to start at 3, right? Because that's our first point. We're going to multiply h of this right here times this, and then this right here, right there, right? We're just going to do 2 multiplications because h is 2 signals long. So that means, actually, I messed this up. It should just be 2 operations. Alright? Is that making sense? So that means if I were to do this, then we're going to do xdfi. And let me pull this guy out. dfi. We're going to grab the third point, okay? And then we're going to go backwards to the first point by how many steps? Well, 2. I'm just going to look at 2. So, actually, let me do something, because I think my x is wrong. Let's see. X. Let's just make this one equal to n. N. Oh. Okay. There we go. So I'm going to do the following. F9. Okay. And let's look at this. So I guess it's still the same thing, length of 3. Minus 1. Oh, I know what to stop doing. We do this. F9. Bring this guy here. I guess it is 3. Nah, whatever. So that means we got to start this one. xdfi 1. We're going to start at I. No, I'm going to put this plus 1 in there. I minus 1 I minus n. There you go, and that's it. And then x dfi, because we're gonna just move everything forward. That means the first point is gonna go, no, we're gonna move everything backwards, sorry. The first point is gonna go backwards, which means we gotta force the final point. Circ shift x dfi minus 1. And then someone has to verify for me this. 2 lines of code. And then let me see this runs. Figure of stem. Yeah, I'll just do this. Y. Invalid use of operator. Oh. End length. How long is our signal? Well, we'll see this. And come on, not today. I have a great idea. Just force this number right here. And then force this number right here. Wait, where is it? Railing? I know what it's talking about. There we go. Doesn't like that size? Come on, man. And doesn't like me. Come on. N. Did I not solve for N? Oh. I know what I did. There we go, that's it. See that? And that's your answer. Just kidding, no. Because you see the pattern. See that right there? And then all you gotta do is you gotta zero adjust this to be, oh, here's your 0, here's your 1, and here's your 2. So
Makes sense.
that should make sense, alright? And then look at this. I can do this. 0.3, 0.5, 0.7, 0.9. And look at that. We can build powerful code just by punching an H. And you can build any filter you want. The point of this assignment is you can sample any impulse response just by punching in numbers. You see that right there? Now you can use this filter, change this to 1s, and see what your thing does. Isn't that freaking cool? Actually, no, I'm going to do this. Sine 0.4 dot times, God, it's going to be asking me for n. Length. Whatever. Actually, what is x? X is 61. Yeah, whatever. N. Dot times unit step. Or this right here is the unit step. There we go. That's the unit step. See that outputs. Sine dot 4 dot times n. Doesn't want me to spit that number out.
Yes, that's it.
Come on. Alright, we just gotta copy this. Where's the n? Go. Doesn't like how I didn't set that one up. Come on, man. Whatever. You know what I mean, right? And that's how you set up these types of codes. go. Yeah, make it 2 units step. Does that make sense? Any other questions? And then the same thing you can do with the transpose direct form too. Whatever value you put into here, your H, you get the same response. And yes, the equations will look the same. Both outputs would look the same. Any final questions? Everyone's going to get 100 on this exam? And a 10 on the next exam? Or 10 on the assignment for tomorrow? Alright. Chat? We're doing good?
Is the convolution function we're going to use, like, it's pretty simple, we just
Well, if you've been looking at my past 3 lectures, yes. Well,
Did you
or
use
no.
the built-in function?
Built-in function, con.
Exercise 6?
Well, all you're going to do for con is convolution just for, well, here's your H and here's your X. All you're going to do is just, well, I don't know, like this. Con X, Y. Con H, X, and X. And then figure 6, 9, stem, Y, F. But you have to make sure you put your N in there. I'm not doing your N. You're going to do this. If you don't, that means I'm taking out points. And look at that, same thing.
Right.
But then you got to do some weird zeroing, but that you'll find out on your own. So, really easy function. Like, literally, this is it. But then your job is to figure out how to zero all this stuff, and it shouldn't be that bad. Any other questions?
What's the meaning of life?
Meaning of life, just do your best. Be happy. All right. Have a good day, everyone. And